Hello, Bio 2.1 folks. I'm going to do a brief tutorial on enzyme kinetics. So remember in class we had this data set shown on the screen here. We had a substrate concentration in column A and the rate of the reaction in column B. And if I graph that data set, I would highlight it like I've done here. Go up to the Insert tab. I'm in Excel now. Go up to the Insert tab and you can go over here to Charts. And I'm going to do just a scatter chart. And if I click on that, it goes ahead and sets up the chart for me. So nice and easy. I'm going to make this a little bit bigger so we can see it. So we have on the x-axis the substrate concentration. On the y-axis is the rate. And this is a typical Michaelis-Menten enzyme. It follows Michaelis-Menten kinetics. And you can see the line is going to approach Vmax, the maximum velocity of the enzyme. And remember that half of Vmax, if you go to half of Vmax, which here would be somewhere around, say, 400 or 500 in the rate, if you go to half of Vmax, you go over to your line and down to the substrate concentration, that gives you Km. Km, remember, is the substrate concentration at which the enzyme is running at half of Vmax. So we can estimate Vmax and the substrate concentration just by looking at this chart. But that's just a visual guess. I would say go ahead and graph your data from our lab and give it a visual guess for both Vmax and Km. And then we'll compare it to our second method of determining Vmax and Km, and that's to use the LineweaverBurk method. So for LineweaverBurk, if you go back to our data, you see I have two columns set up here. One for 1 over the substrate concentration in column D, and column E is 1 over the rate. So I'm going to ignore 0, and I'm going to start at the substrate concentration of 1. And I'm going to input the data in column D by starting on row 3 and just say this equals, type in the equal sign, 1 divided by, and then I'm going to highlight column A. Hit enter, and that gives me 1 over column A. To copy in Excel, it's very easy. You highlight that cell that you'd like to copy. On the lower right, if you put your cursor over that, it comes up with a plus sign. If you click and drag down, it copies that cell all the way down. So now, quickly, I've input 1 over S for all these data. I'll do the same thing for the rate column. Column E, hit equals, 1 divided by, and highlight column B. Hit enter, and now I've got 1 over the rate. Highlight the lower right corner till the plus comes up. Click and drag, and now I've copied that all the way down. So I have my data set for the LineweaverBurk plot. If I highlight that data set, I can go back to the Input tab up at the top of Excel. I'm sorry, the Insert tab. Click on Charts. I'm going to click on the Scatter Chart and do another scatter plot. All right, so it's gone ahead and input a chart. Let's blow that chart up to make it a little bigger. I'm going to move the chart location. So up at the top, if you go to the right, you'll see I'm highlighting the Move Chart Location right now. Click on that, and I'm going to move it to a new sheet so it's all by itself. So click on New Sheet, hit OK, and now it's in its own window. All right, I'm getting close to being done. I highlight the data set, right-click, and I say Add Trend Line. The dialog box pops up. Sorry, having a little trouble here. Get out of this. And what I'm trying to do is move the dialog box so you can see it. There it is. All right. So it's going to be a linear trend line. Make this a little bit bigger. A linear trend line. So I'm going to click on linear. And I want to project this backwards. I don't know exactly how far, but I'm going to guess it's about 0.4 periods. And I'm going to display the equation on the chart. All right. So if I hit enter there, I should get some action here. Let's see. Nothing happening. Nope. There we go. Now it's come through. All right. So a couple things have happened. I've displayed the equation, which I'm highlighting here, and I'm going to make a little bit bigger. That's the equation of the trend line. And you see I projected it backwards so it intersects the x-axis. So remember that the x-intercept is minus 1 over km. And the y-intercept is 1 over Vmax. So you can use the y-intercept when x equals 0 to determine 1 over Vmax. So if x equals 0 in our equation of the line, the equation here, y equals 0.003x plus 0.001, if x equals 0, then y equals 0.001. So that's our y-intercept. So you can use that to determine Vmax. Simply, if Vmax equals 1 over 0.001, then Vmax equals 1,000. We did that in class. Oh, the dog is getting excited about something here. I don't know if you can hear that in the background. All right. If we want to determine the x-intercept, then y would be 0. So we'd set y equal to 0 in our equation, and our x would be minus 0.001 divided by 0.003, or minus 0.33. So minus 1 over km equals minus 0.33. You can use that to determine km. This is the same thing we did in class. All right? So if you follow these same procedures for the data set we created in class, you can do your Michaelis-Menten chart and your LineweaverBurk chart. Let me know if you have questions. Hopefully that helps. Thanks for tuning in, and I'll see you in class.